Welcome to all. See, today's class is Engineering Mechanics Part 5, class number 320 for Part 5, Lecture 3. You can see there. Now, see, class 317, I wrote Part 5. What I have done is, you know the title, Analysis of Statically Determinate Pin-Jointed Plane Frames, that is same. There, I did not mention or told here in the class anything about pin-jointed frame. Simply, this class was pre-requirement. I wrote pre-requirement for method of joints. That class I told, what is method of joint will come later. Because this class we simply considered equilibrium of a concurrent force system which repeatedly comes in method of joint. So first all of you thoroughly go through this class without bothering what is pin jointed plane frames. Okay, next. Class 318 is the lecture number 1 for analysis of statically determinate pin-jointed plane frames. Here, I explained what is pin-jointed plane frames. So many things are explained. This is full theoretical class. Go through this class also. Then, last class, class 319, was a master example for method of joint. And one more thing, I told procedure is still not given. So actually if you go series wise, after this class, then today's class, and then this class. But today, this class means today something we will be telling, I will be telling something today. That is required for this one. But this class I told everything what is required. Or you can do one thing, go through pre-requirement class, go through all explanation and thoroughly study this one. Okay, now I will start today's class. I will write procedure, come explanation for method of joints. So go through this class thoroughly. There are so many concepts are there. Okay, first make a note here. First I will dictate something here. When you analyze a pin-jointed plane frame, analyze or analysis means finding axial force in the members. Maybe all the members or some members, that I will tell later. Okay. So purpose is to find axial forces in the members. Axial force can be either tensile in nature or compressive in nature. That all I explained last time or earlier also told. So there are two methods are there. One is method of joint briefly. Other is method of sections. No. First remember, method of joints, method of sections we will consider later. Remember, method of joints, see this is I told, procedure come explanation, both are there. Method of joints is usually used when forces means, okay, when axial forces in all members are to be obtained or are to be calculated. Okay. Make a small note here. After finishing method of joint, we will go to method of sections. Remember, method of section is very ideal when you require forces only in some particular members. I will tell later, not right now. You can add it here. A small note, see, in the bracket you can make a note. Later, the other method of sections, it is very useful, or it is employed or used when axial forces in some of the members, some selected members are required. Not all. When forces in all members are required, method of joint is the most ideal. There also you can do it, but lengthy procedure. But method of section is very useful when you have to find axial forces in only some selected members. Okay, that note you write. Then, in method of joints, see, it's very important. In method of joints, we consider equilibrium of joints. The term joint means a point where different members are meeting. This all I explained last time. Joint. First of all, people know all these things. No need of explaining further. They know what is a joint. Different members are meeting. Okay, now, very, very important. When we consider equilibrium of a joint, any joint of a joint, we get a concurrent force system. Concurrent, or some people call concurrent. Okay, that is depending upon pronunciation. I will pronounce the way I was taught when I was first studying English. Concurrent force system. Very, very important. Make a note further. We already know that a concurrent force system is a force system. Actually, concurrent force system means actually coplanar. Very important. Coplanar. A coplanar concurrent force system is a force system where all forces are lying in one plane. Line of action of all forces are in one plane, and line of action of all the forces passes through a common point. You know it in the beginning of engineering mechanics. Okay, now, therefore, see, basic conditions of static equilibrium applicable are sigma h equal to 0 and sigma v equal to 0. That's all. Right, which earlier we used to call sigma fx equal to 0 and sigma fy equal to 0. Make a note. Sigma, just make a note here. Note. Sigma m equal to 0 is not applicable. Because when all the forces are passing through one point, it is not applicable. Is not applicable. I give all the here. This is procedure come explanation. You should understand everything. Okay. If you want only procedure, by going through this class, you prepare a separate procedure. Okay. In the notes I will write that also. After everything is over, I will write there. Now exclusive procedure. Okay. Sigma m equal to 0 is not applicable. So therefore, very, very important. See, therefore, only two conditions or two equations are available. Two equations are available. See, that is based on what? Based on sigma h0 and sigma v0. Therefore, make a note here first, one note. we can solve a set of equations, simultaneous equation, only when number of unknowns is equal to number of equations. If number of unknowns are more than number of equations, we cannot solve mathematically. Here, structural analysis, it will go to indeterminate structure, not here. It will come in indeterminate. Don't worry now. But number of unknowns cannot be less than number of equations. It becomes unstable. So, number of unknowns should be equal to number of equations. Therefore, see, very important. Therefore, red color, see, when we consider equilibrium of a joint, there should not be more than two unknown forces. There should not be more than two unknown forces. Now, what are unknowns? See, now further, at a joint, unknown forces means axial forces in members connected to that joint. Okay. Next, one more note. Make here. I will dictate here. You should write. When we consider a joint, see, support reactions may be acting there that are not unknowns for method of joint, because before you start method of joint, we are going to first find support reactions. Make a note. So support reactions are unknown for equilibrium for entire frame. It is not method of joint. So someone will tell, sir, if unknown is support reaction, no. In analysis of statically determinate pin-jointed plane frames, when you consider a joint or before you start method of joints, first step is to find support reactions. So once you find support reactions are not unknown. Okay. Next, one more point. You make a note, one more point. See, I am dictating because this all I cannot write. People who are serious will write it. At a joint, it is, see, just now told that there should not be more than two unknowns. And also I told unknowns are axial forces in the members. That does not mean that you can consider method of joint only for the joint where two members are meeting. No. Only for the joint where two members are meeting. Everything I am dictating, right here. There may be any number of members. Right here. There can be any number of members. But unknown member forces, unknowns should not be more than two. Therefore, right here. Therefore, at a joint, when you consider a joint, if there are two members only there, both can be unknown. What all I am dictating, you write here. See, if there are only two members there, both can be unknown. Next, below right here, if there are three members there, among the three members, one member force in one of the members should be known to you, so that unknown is still two. Or if there are four members are meeting at a joint, among the four member axial forces or unknown forces, among the four, two should be already known. So only two more unknown. Or if five members are meeting at a joint, among the five member axial forces, see, 3 should be already known. Only 2 should be unknown. Therefore, you can conclude that irrespective of, see, you can conclude now that, you can write here, therefore, see, therefore, we can conclude that irrespective, see, this is actually irrespective is only 2R. I put a multiple R to stress it, irrespective like that. Irrespective of somebody, an object, it is not English, okay, special English. Irrespective of number of members connected to that joint, irrespective irrespective means does not matter. Irrespective of number of members connected to joint or number of members meeting at that joint, when we consider method of joint and apply equilibrium equation, equilibrium basic condition of static equilibrium condition, okay, equilibrium condition, number of unknowns, number of unknown member forces. Actually, I don't want to use word, but in this chapter, now onwards, to save the time, every time I cannot tell, instead of actually axial force in the member axial forces. Difficult, right? So in future, I will tell it later. If I tell a member force, it is understood that it is axial force in the member. So number of unknown member forces should not be more than 2. Right here. Should not be more than 2. Okay, that is one rule. Somebody, no, one doubt right here, doubt. Somebody may tell, sir, there are 3 members acting there, sir. Which 2 you have to take unknown? Not which 2 you have to take unknown. You have to consider all members. If 3 members are there, one of them should be, force in one of them should be already known. Sir, how you know it? How you know it means maybe this joint is not first considered. Some other joint are already considered. When you already consider some joint, there same member will go and meet there also. See, every member has got joint at both ends. Maybe other end of the member already, that joint is already analyzed and member force found out. Therefore, by the time you come to this joint of 3 unknown members, that member force already known, only 2 unknowns. Right? Anyway, that you can observe in the last class, exclusive example or master question for method of joint. Okay, this much important. Okay, now I will write somewhat step-by-step procedure. It's all basic explanation. Okay, now I will give procedure. What all I explained so far, even though I told in procedure, it is somewhat explanation. See, first step. See, I'll put star mark here. Okay, first step. First, find support reactions. Support reactions, very important. See, support reactions, if required. Someone will ask, sir, what is that if required? Support reactions, if required. See, if this if required is separately considered. See, note. Okay, see note. Okay, I will give note here. I will give a note here. Note. That is, you may do a mark here. If required, do one thing. Put a star mark, if required. Okay. See note, star mark note. Star mark note. You make a star mark note. Somewhere, see, write somewhere here only, but some extra explanation is there, I will tell you. See here. If one support, see note, first note, if one support is hinged, remember hinged is, or some people call pinned, both are same, pinned, and other support is on rollers, then we have to find support reactions. I will give example for you. See. Okay, 1 minute. For example, you can write here, example. See. Simple trust. I won't give too much of big sketches here. See. Yes. Support reactions are required. Right here. Yes. Support reactions are required to be calculated. Or, see. Sometimes they give this way. See, vertically they place it. No problem. This way. Okay. One hinge, one roller. Right. Yes. Support reactions are required to be calculated. Okay. Then 2. Sometimes two simple supports may be given. Simple supports may be given. Remember, make a note here. Then they should not apply any horizontal load. Like simple support beam. See, that is, see here. Like, they will give a truss here and they will give, see, simple support. Actually, this can be in equilibrium only if you apply vertical load. Here, you can apply any load. Horizontal load also possible. Why? Hinge is there. Here, horizontal load not applicable. See, here, horizontal loads should not be given. So, here also, right, see, here also find support reactions. Here also find support reactions. But of course, how many? Here, see, support reaction means, I'll tell you here, then we have to find support reactions. See, total 3 reactions, that you know it. Or you can do one thing. You can write there, see, you can show the support reaction here if you want. See, show a support reaction here. Here also, see, show a support reaction. Red color, support reaction. Here also find support reaction, that is 2 vertical reactions. No horizontal reaction. Vertical. Now here, next. 1, 2. Now very important, 3. Don't worry about it here. This all is what? Note for this one. I will write here and rub it out. 3. Consider a pin jointed frame with 2 hinged supports. Like that is, see here, maybe, see, I'll put here now, see. This I'll explain it later, see. Hinge support. There should not be a member here, very important. Some loads are there. Or, see, this way, with the two hinged support. Here, hinge support, but without a member, very important here. Here, see, consider two hinged supports. See here, I'll continue further here now. Two hinged support right here. Very, very important. Without a member connecting the two hinged supports. Connecting the two hinged supports. See, no member here, no member. So, or you can make a note here. I'll take A and B here. A and B here. Make a note here. Make a note here. Now, two hinged support means each support two reactions. Horizontal, vertical, horizontal, vertical. Total number of unknown becomes 4. But equilibrium equation for reaction finding is 3. See, when you find reaction, sigma m also applicable. Sigma m is 3. Sir, how to find reactions? Nothing to worry. See, there should be without a member connecting the two hinged support. So right here, member connecting AB, they should not give a member here. They should not give a member here. Yes, in question paper, so many examinations they give it. Okay, so many examinations they give that one. Then, very, very important now. And also, see, one more sketch I will give you. Also, sometime a question can be given like this. See here. A question, same question. See, I will put here question 1, question 2. Or make a note here. Or question 1 can also be given as, see here. This way. See, A here, B here. And question 2 can also be given as, see, like this. Make a note here. AB, see, AB. If I take, don't by heart AB, A and B. Make a note here. Above two questions, see, if we see the previous two examples, crystal clear, hinged support at A, hinged support at B. Okay. But here, sudden what people will tell, oh, base is fixed. Here, the vertically a fixed support is there. First of all, make a note. First of all, make a note that fixed support in pin jointed plane frame is not considered, is not there. When you go for pin joint plane frame, the fixed support is there. Fixed support will have vertical reaction, horizontal reaction and reacting moment. No, bending is not considered here. So therefore, even if they give fixed here, right here, write this way. Therefore, now very important, here make a note. AB is not a member. Very important. AB is not a member. Here also, AB is not a member. Not a member. And also make a note. Also, right here, also make a note. Here, the members are not fixed at A and B. Here also, members are not fixed at A and B, not that fixed. So, even if it is not mentioned, even if it is not shown, A and B are hinged support only. Hinged support only, understood. There is no hinged support only. That is, you write here, if the question is given like this, you rewrite it as, see here, you can rewrite it as, when you solve, see, okay, space problem, hope you understand. This way, see, this will do, or see, this is not a member right here, AB. There is no member connecting AB. Here, you can rewrite this as, see here, you tell, or you can do it this way, see, or see here. This way you can rewrite it. Okay. Now it becomes once again, see, same as this case. Okay, now one last note. Sometimes this, see, now one last note. In some questions, sometimes they give sketch like this, but how they will show the question is, see, this is by a person who knows the subject. See, if a person is knowing the subject, even if he shows this way, or even if he shows like this, see, a person who knows the subject does not mean that when some questions are given examination, they do not know subject. But so many times they don't consider those things. So then what he will do is, see, he will give like this. See, A, B. Right. Oh. Then once again, it becomes our same case, what? Two hinged support. See, AB is not a member. This is some plane, some surface. AB is not a member. Not a member. Here also, see, AB is not a member. Right. Therefore, this is the case of, right here, I told just now, when two hinged supports are given. So remember now, so for this, all these cases, lastly right here, for all these cases, already, see, make a note. I first told note 1, note 2, note 3. This is note 3. In note 1, see, note 1, first one, I told support reactions required. How? One hinge, one roller. See, remember? I don't know how it is given there. Forgot it. Okay. Something I will show it here. I already told you. See, reactions are required. Reactions required, and then or. If they give two simple supports, right here, reactions are required. But for the last case, that is 3, there is no need of finding support reactions. Then make a note here. These are all the explanation for my procedure where I told first step is find support reaction if required. I am explaining that if required. Make a note here. I'll dictate. Does it mean that there are no reactions for this one? No. Reactions are there. But you need not find it. You can solve the question by method of joint without finding reactions. Okay. Therefore, last right here, for last case, last right here, for this last case of two hinged support with no member connecting the two hinges. For the last case of two hinged supports with no member for connecting hinges, see a separate note. See a separate explanation little later. Little later means, I will do one thing, little later, you have to wait for some time. Wait for it. Right now, I don't want to confuse you. Right here, wait. You may write a note there. Why he is asking us to wait? Right now, I can give, but it will give mix-up for you. Therefore, for this one, you wait for some time. Let us complete some questions by method of joints. Once you get the firm grip, then I will introduce that one. I will give an explanation at that time, and I will tell you, you can read this in the beginning only. Okay. Wait for some time. It will be explained when time comes. Today I'll tell you one thing. Before I started recording, I wrote these sketches somewhere here and decided to explain the concept today only. But then I decided, we are not still started method of joints. Procedure is still pending. And we are in the beginning. In this time, if I tell this extra concept, many people get confusion. Therefore, no. Let everybody wait. I will tell at that time. A separate note later. So, I will tell later. See, earlier I told wait for some time. Now the time has come. Okay. Now do one thing. I thoroughly explained. See, first find support reactions if required. See note. 1 minute now. Okay. Now, to understand correctly, now procedure once again. Okay, start. Again write. For method of joint. See, now this is the best one. First find support reactions if required. Now, right here. Now, we know what is that if required. You write here. What is that if required? He told. You can make a note here. If required means make a note here. See? Make a note here. One hinge and other roller reactions are required. Two simple support reactions are required. But two hinged support with no member connecting them, reactions are not required. See, one hinge, see, here three reactions, see, here three reactions. Here three reactions. Here only two reactions. Here four reactions, but not required. First of all, four reactions you can't find. Or I will tell once again now, I won't repeat again. One hinge, one roller. Write by words. Sketches you can write later. One support, hinge or pinned support, other roller reactions are required. Two simple supports, actually unstable for horizontal load. See, if they give two simple support, they cannot give horizontal load. They will not give. That much common sense will be there for him. So, one hinge, one roller or two simple supports reactions are required. But two hinged support or pinned support without a member connecting them, that in between connecting member should not be there, support reactions are not required. Right here, what to do, he will tell later. He will tell later. Okay. So when I start that question, I will tell at that time. Okay, now write over. Next step. Okay, continue. Next step. One important note here, for finding support reactions, see, for finding support reaction, we consider coplanar force system. It is not concurrent force system. Therefore, three equilibrium conditions, namely sigma H0, sigma V0 and also sigma M0. When you find reactions, three equations are there. So three unknowns you can find. Okay, next step. Now come to next step. Next step, I start here. Next step. Okay, 1 minute now. I'll rub everything and start next step to make it clear. Now, next step. After finding support reactions, note only if required. Already explained. If you are finding if your support reactions are required, find it. If not required, leave it. Okay, then find angle of inclination for all members. How? Use trigonometry. Find angle of inclination for all members using trigonometry. Inclined members. See, preferably with horizontal. Why? Reason, tell me. Reason is, if you consider the angle with horizontal later, and remember, nearest angle less than 90 degrees. All angles should be, theta should be less than 90 degrees. Very important. Then horizontal component is cos, vertical is sine. You know it. Okay, then. Now the most important. Draw a neat sketch of the given pin-jointed frame where show all the given external forces. Enter the support reactions if calculated in the actual directions, that is without sign. Suppose you consider reaction. See, when you find reaction, you are assuming direction. If it is positive, you make a note here. If it is positive, assume direction is correct. Enter in the same direction. Suppose you get negative, don't enter negative sign, enter it in this sketch, in a direction opposite to the assumed direction. This all you know it. Okay, then. And also mark angles for all inclined members, preferably with horizontal. Remember, this second sketch, in future, I will consider as a star sketch. Remember, now onwards, I will refer the second sketch as a star sketch up to some questions. Once you got familiarity, I won't write. Some will tell, sir, this time you forgot to write star sketch. What you are doing? Already 8-9 questions are over. Still you want me to write. So I will refer as star sketch. One important. The star sketch is the master sketch. Remember, this is the master sketch. Very, very important. I will tell you why. Little later I can make. Okay. See, yesterday, I told it last class. Next, start method of joints. Start method of joints. Select a joint where number of unknown member forces. See, even if I call unknown member forces, technically it is called unknown axial forces in the members. See, I never call moment, I call bending moment. I never call force, I call axial force. But here, difficult, right? Each and every class, axial force. So, member force. When I tell member force, it is axial force there for the member, either compression or tension. I told you, where number of unknown member forces is not more than 2. Select a joint. where unknown forces are not more than 2. Okay. Then draw free body diagram. Then of that joint. Now class. I will dictate something. First put a dot. That dot is the joint. Better draw one dotted vertical line, draw one dotted horizontal line. One of them is horizontal axis, other is vertical. Okay, then for which equilibrium will be considered now. Now, very, very important. This I will not tell each and every class. See. You follow all the steps correctly, solve some 3-4 questions, you will become master. Very, very important. See. When we consider the joint, any joint, I already told you, number of unknown should not more than 2. We have to consider, what all you have to consider? We have to consider 1. First one. See, support reactions on that joint from supports, you have to consider support reactions on that joint from supports if that joint is connected to support, connected to a support. Now, one doubt will come. Somebody will ask right here. In the class, somebody will ask me, sir, you told sometimes support reactions are not required. Yes, I told. Then what to do? Then do not consider their joint. That's all. You write here. If support reactions are not considered, then you should not consider that joint. That's all. Then how to solve? Other joints are there. Don't worry. Solution is there. If support reactions are calculated, you consider the joint. If support reaction is there, but if reactions are not considered, sir, what to do? Do not consider that joint. That's all. Over. Then 2. Support. Remember, when you consider support reaction, consider in the actual direction. I told you. Second one. See, second one. All external forces or loads, anything, loads on that joint. See, note, this is given in the question. In the question given. Now the third one, most important. All forces acting on that joint from members connected to that joint. Connected to that joint. All member forces, all from member connected to that joint. Remember, some people, they will tell these two are external, this is internal. No, this also is external. I will take separate YouTube class later for this one. That is for those who are having wrong version. Right now in my class, you believe me, I cannot tell wrong on these things. Do you think I can tell I can make a mistake in such concepts? Never. Okay. Now, see, all forces acting on that joint from member connected to that joint. Note. Some of the member forces. No, not that way. I am setting a joint. No. Note. What about direction? Direction for unknown member forces. Member forces. What about direction for unknown member forces? Answer, see. We have to assume or consider the direction. Direction for unknown member forces. Member forces on that joint. On that joint. That is either acting towards the joint, see, towards the joint, or acting away from the joint. Away from the joint. Okay, right. How to decide? How to decide? Okay, now, answer by me. You should write, I am dictating how to decide. If we use little logic and think, it is possible, you should write everything you are right. It is possible to decide the correct direction. Maybe 90% case we can decide. Some will ask, sir, how? Wait, I am up. After everything is over, I will go for that also. I will tell how direction for unknowns can be correctly decided using not brain actually, sometimes common sense or sometimes little observation. So, if possible for you, do it. Because it is always better when if you go to an interview, if you mark the unknown wrong direction, somebody may tell, you think it is this way? No, sir. Then, sir, no doubt. See, you are supposed to know this one. Tell me. You don't solve. How it will be? This way or this way? I will tell. It is this way or it is this way. Sometime I will tell. No, right now I cannot tell. But I can tell if you give me some 10, 15 seconds or 30 seconds more time. Give a calculator. That means it can be anything depending on other values. Then he will tell, okay, leave it. Okay, now. How to decide? So right here, possible. For which, right, he will upload not only for that one, some more concepts are there. He will explain later. But right here, but suppose it is difficult or people who do not want to see no time. See, this force is that member in this way, it will be this way. Instead of, if you feel, do not want to think and waste time, then, but suppose you want, then randomly assume direction, over. Assume direction. Either incoming or outgoing. Right here, either acting towards the joint, you can use incoming or outgoing, not telephone call, or going away from the joint. Okay. And name it. Name the force by P, X, Y. X is that joint, Y is other end joint. P, X, Y, like that. Okay. Instead of P, you can call F also. Sometime in examination, they can give a question where external load is given in terms of P. Then instead of P, I will use F, FAB, FC, FAB, FBC, like that. Usually, I will use P, PXY, PAB, PBA, etc. Name P. Okay, then this assumption is over. See. I'll continue procedure now. Okay, this is also over. One, make a note here. One very powerful note you have to make now. Note. after the joint is completely analyzed or unknowns are calculated, always calculate unknowns with sign. Positive sign indicates that assumed direction is correct. Negative sign indicates that assumed direction is wrong. Write that way. Now, next. Next is only for those who find difficulty. Use a pencil and for inclined members, resolve slight arrow mark, write which is cos, which is sine. I don't require it, but I usually write it up to some time. This I told, I have shown. Sine, cos, examination, better not write it. Some people get angry. Use pencil. Once your joint is over, rub it out. Okay. Next. Now, apply the two basic conditions of static equilibrium applicable for a joint, right here, applicable for a joint, that is sigma h0 and sigma v0, right here. Now, one doubt comes. Which one first? Make a note here. Which one first? Note. I will dictate. See, inclined force will come in both sigma h and sigma v. But pure horizontal unknown will come only for sigma h. Pure vertical unknown will come only for sigma v. Therefore, it is better to observe there. If one unknown is inclined, other is horizontal, eliminate horizontal by applying sigma v first, right here. Eliminate horizontal by applying sigma v first, then apply sigma h. Or, if one unknown is inclined, other unknown is vertical, eliminate the vertical by applying sigma h0 first, then apply sigma v0. Next, right, if one unknown is horizontal, other unknown is vertical, never bother, apply anything you want. Or, suppose both unknowns are inclined. This all I have shown in the pre-requirement class. If both unknowns are inclined, don't start worrying elimination all. Apply sigma h0, sigma v0, whichever first you want, you will get a simultaneous equation. Make a note. Okay, now, next, after over, see, always make a note here. When you solve, always sign, you should be very careful. And lastly, right here, and lastly, get unknown member forces acting on that joint with sign. With sign is very, very important. Now, most important part. Most important part. Once your joint is completely analyzed and you got the unknowns, I am dictating, you go to star sketch. Now onwards, full dictation. Go to star sketch. Hold the finger at that joint. See, someone will laugh. Hold the finger. I will tell, okay, you laugh, no problem. I want to teach so that everybody will understand. You are high level, if you want to talk, come with me. I will talk high level. Do you think I cannot talk high level? But when I teach easy way. So don't comment on those one. Put a finger at that joint. Then see what direction the unknown is assumed. You should write everything. If the result is a positive, if the unknown value comes with the positive sign, in the star sketch, enter that value in the same direction as assumed without sign. Okay, then in case you get negative, that means assumed direction for unknown is wrong at that joint. When you put the finger in the star sketch, enter the value at that joint in a direction opposite to assumed direction. Okay, enter the value. Over. Immediately enter the values at the enter the direction at the other end opposite to the direction at the end where you solved. That means, see, I'll tell you here, that means when a member is here, suppose you consider this joint, see, this joint consider. If the entry is like this, something, say 21.8, immediately, see, enter opposite here. Or suppose same joint, if the entry is like this, how much? 21.8. Immediately enter the arrow mark there. Value right in between. Answer right in between. Therefore, note, both end forces are known. One end we got by method of joint, other one direct entry in the star sketch. Okay, now procedure further continue. Proceed, and then till you get complete grip, take a photograph of the sketch. Take a photograph of the sketch after the first joint and take a printout and attach. We reached this stage. Okay, over. The next step. Now I'll do one thing. I'll dictate. Next. Select a joint referring to the star sketch. Referring to star sketch. Select a joint referring to star sketch. Very, very important. Select a joint referring to star sketch where number of unknown member forces again is not more than 2. Sketch the joint. Forces to be considered same thing. Support reactions if it is there, then outside external forces whatever given and member forces connected there. It is possible that some of the member forces is already known to you by analysis of the other end joint. So therefore, in the star sketch, if any member force is already known, you name it in that joint first and enter the numerical. It is not unknown. So lastly, unknown not more than 2. Okay, now I will stop the writing. Continue procedure. Again apply sigma V0, sigma H0 and get unknown forces. Immediately enter in the star sketch. Cumulative entry. That way complete the procedure or process till forces in all members are calculated. And make a note, each time you enter in the star sketch, result from a joint and immediately other end arrow mark. Take a photograph and preserve it so that stage by stage you will be knowing. After completing the question, if you look at the star sketch, complete answer you can make out, but then you have doubt which is unknown like that. Therefore, it is better to take intermediate sketches, each entry in the, as soon as you enter in the star sketch, result from the joint and immediately other side entry, reverse, opposite. Take a star sketch and attach. This you do till you get perfection. Complete the procedure. Then, if they ask tabulation, you prepare member, force, nature, member name, force, write the value. Nature means either tension or compression. I told very clearly. Now I will not tell. See, member force going away from the joint, tension. Sorry, now I will not tell. Compression. This way. See, you should not see how it looks like. See the joint. If the force goes away from the joint, tension. If the force comes and hits the joint, it is compression. Okay. Now complete. stress completely, analysis over. Now, just one practical example for you. Why intermediate photo required? I will tell. Imagine you construct a building. You don't take any photograph. After the building is completed, that is, after star sketch is completely over, you invite people for the house opening ceremony. They will come and tell, oh, beautiful building, etc. They will attend the function, eat well, and hope you all the good luck. Some will give gifts also for you, and go. But those who came, a person is there who will ask, see, I also want construction. So please explain me procedure, how you have done it. You take building, see, you tell, see, first you prepare the layout for this one and digging soil, go for bed. Where? How to go? See, he won't understand. Then bed concrete cleaning, you tell footing, reinforcement placed, then column centering all over, pour the concrete, stage by stage, see, it will come this way, then slowly come to ground plinth level, then do something, then what? Raise the building. He won't understand. So what you do is, he can see full building. See, after you finish the question and when you study later, you can see full entry. So what to do is, when you construct a building, who knows, maybe tomorrow, people may ask you, you are a good person, you are a person who want to help the people. See, here, you are a person who want to learn the subject. There, he is a person who want to help others by showing different stages of work. As soon as everything is ready for laying foundation, he will take a photograph. You can see, my site was like this earlier, empty. Once he places the bed concrete, one more photograph. Place the footing reinforcement, one more photograph. See, still then, after footing reinforcement, place the column reinforcement, etc. and photograph. Put the concrete, let the column come to some height, one more photograph. Then, as it comes to ground level, plinth beam layout, etc., whatever preparation is doing, one more photograph. Go to lintel level, one more photograph. Roof level reached, one more photograph. Centering for the roof, with all people, reinforcement there, no concreting, one more photograph. Concreting done, one more neat photograph. That way, complete building structure is over. Again photograph. Start finishing. If you do that way, a person who comes, he can make out, oh, this way he came. Otherwise, if you finish everything, enter in the star sketch, later when you study, see, suppose later you open your book, this is IS code, open your book and see, oh, hey, what is this? Every force is known here. How to start? How to start means the photograph taken stage by stage will help you. Okay, that much is sufficient. Procedure over. Now I will tell you what I will do. I will next class, I will start a problem. Important question once again. Now see, procedure known for you, master example already over, pre-requirement already over. What further you want? You should be raring to go now. So next class I will do again a master question. But this time little explanation will be lesser because I won't waste time here. Sigma H, sigma V. Okay, maybe some questions I will write, but every question I will tell you solve now. See, after some time I will write joint equilibrium. I will tell enjoy, calculate, mini exercises. So then once next class question is over, then I will tell two things for you. One, how to decide the unknowns using concept. Of course, some will tell, sir, no problem, sir. I am not worried too much. Why? I will take random, sir, because you told no. Yes, sir, I have no capacity, sir. What you told, see, this force is this way to balance you require. No, sir, I have no time. Okay, done. But people are there who want to learn. How to decide, if possible, 90% possible. Second one, there are three important rules. 2-force rule, 3-force rule, and 4-force rule. Those rules are very useful when you solve the question. And I will do one thing. When I solve my next question, I will see that those rules are applicable. So that I will not mention the rules. I will solve the question. So that once I finish those rules, I will tell, now see the previous question. Oh, yes, sir. What you told is correct. See, your 2 force rules are applicable here. Very good. See, 3 force rules are here. 4 force rules are here. Yes. So that later you can use them. One is 2 force rule, 3 force rule, 4 force rule. I will explain everything. Okay, now that's all today. Procedure fully given. Using all this, if you want, you can do one thing. You prepare your own procedure, which will help you. Actually, in the notes, I will do one thing. After all this over, I will write there procedure. There I will put just procedure without explanation. I will write there. For if you want any other extra explanation, refer to the class. See, class is universal. Anybody can access. Okay, that way I will write there. So, next class will continue. First, I will start numbering the question now. See, last time I numbered master question. I have not numbered it. Next class, I will go for question number 1. So actually, if I finish 10 questions, it is actually 11 questions. Why? Starting master question. But master question, so many things I am not told. Therefore, leave it. It is a master question without name, without number. So next class, question 1. Okay. Thank you. We'll meet in the next class. Everything go through and understand. Okay.